guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. If I can make it through this and the phone doesn't ring. Gentlemen, we're going to do a multi-part video. This is going to be a long one. It's going to be fun. What we got here is a Dave made. And it's for my friend, Mr. Curtis. Curtis is a nice gentleman. He's been very, very patient with me. And this is like the third project or fourth project I've done for Curtis. This is a Dave made 1x2. We are going to transform it into a 1x4. Okay. Now, you guys might remember Curtis. This is from one of his latest hits. This was his old amplifier that he had here that I stripped all the guts out of, everything that I thought was usable. And we built him a whole new board and whole new amp. Yeah, I'll put the link to the video in the notes below. I forgot to send this board back with his other amp, and it's been sitting here patiently waiting. Curtis has called me twice. Can you send me back the board? I think he wants these transistors out of here. God, I don't know why, but let's see. That one's... The ones that don't say T on them are bad, by the way, Curtis, just so you know. Anyhow, this will be coming back with this amp, Curtis. So our mission, which I've chosen to accept, is we're going to convert this old skunky Dave made. First, we're going to clean it all up. Probably go through and replace most of the screws and the cabinetry on it. Place all the screws on the bottom. Make it better. We're going to repair the remote. I'm going to have to disassemble the Anderson clip. These are soldered in. I'm going to unsolder these. We're going to upgrade the power wire. Listen, I'm not a big fan of Archer products as a whole, but I'm here to tell you this Radio Shack fan can move some friggin' air because the blades are so thick. We're going to put a new fan in there for you. A thin, sleek, high-flow fan. Because if you notice, it's missing one of the screw jobbies here. And that was so it wouldn't hit this transformer. Here. Going to replace your on-off switch. We're going to give you a new LED. Variable feels good, but we're going to test it. But we're going to stick with the Dave made style transformers. I got a bunch of those in stock. Just chilling. So... we're going to rip this thing down. I'm pretty sure that that's a knockoff Toshiba. See, if we look at the two next to each other, you see the color and the print difference, and I'm pretty sure this is a knockoff part, but we are missing the 10 ohmer here, so at some point or another this quit. And we're going to have to upgrade the relay. We're basically going to gut this thing and start over. I'm going to clean this all up. We'll change this 2290 out to a 2879. And we are going to do the HGs. So that's the intro for this this particular guy, and this is what we're going to work on today. So first order of business, before we go through all the cleaning process and stuff, I am going to drill and tap out the holes for the transistors and then go from there. Guys, away I go. As much as I hate doing this by hand, I don't really have a choice. I could strip the whole cabinet apart and take this over to the drill press. I have this very powerful tool. It's called a clutch-o-matic. What the clutch-o-matic is it measures in inch-pounds the torque that's being applied to it. So it's really a screw machine. It's really a screw machine. And what I mean by that is it's designed for tapping screws. Now this really soft aluminum is super vulnerable to galling the bit. And the bit breaking. And there's a lot of little intricacies that go along with drilling this stuff. The clutch-o-matic, if you torque up on it with the bit, like the bit's going through the aluminum stock, what'll happen is, I got a piece of heatsink around here. I know I do. Here. What happens is you're drilling through the heatsink, your bit for the transistor will go through, and if there's nothing in the bed area, the base here, the bit will pass smoothly through. But every so often you're going to catch it where you're half on and half off the heatsink fin, which will cause a differential in torque. And what I mean by that is half of the drill bit is going to have a loaded amount of energy on it from being into the aluminum, and the other side isn't. And it'll cause the drill bit to shatter. So usually before you drill out your transistor pattern, I have a jig that I can lay out on the heatsink that I have made of stainless. It's got pins that stick up off the edge of the jig where the screw holes would be, so I can lay the jig out and physically move the jig back and forth and line up my transistor holes so they miss the fins. Well, we're kind of missing that luxury by drilling this in cabinet. Oh, there goes the phone. Hold on a second. I can't have that luxury here. We're drilling this in the cabinet. So I start out with an incredibly small pilot bit, and we're just kind of probing it out. Now the worst thing that happens is this bit busts off in the heatsink. Then I have to strip the whole cabinet apart. So I have it set on the lowest clutch setting, like literally. I don't think that's going to save me, but the pilot bit went through. Perfect. Now, the number one thing that will cause a transistor to fail is if it doesn't have the ability to sit perfectly flush. By the way, this is a Milwaukee 3/32 bit. I used it for 4 holes, and this is where I file it. As soon as I'm done using this bit, I will never use it again. Perfectly good bit. I've just found that it's not worth my time and energy. Look, $2.30 or $3 bit, which is a good dollar. This is a good bit. It's not worth my time if this bit fails me again in the future. I'd rather throw this away than take the risk of running it and snapping it off in the heatsink. All right, guys, on to the next step. The number one thing that will cause your transistor to fail, as far as this is concerned, is that you have a little tiny piece of aluminum gall up where you drilled your holes through the heatsink. And it'll ball up, and it will cause you to have the transistor surface, the flat surface of the transistor, instead of it sitting smooth on the heatsink surface, it's going to get kicked up just a hair. That just a little bit of differential will cause that transistor to pop. I can't tell you how many boxes I've had come through here. And listen up, everybody that watches my videos and tries to learn how to do this. How many boxes I've had come through here where the transistor keeps blowing up in the same spot. After you've eliminated all the other things around the transistor, all the capacitors and all that kind of thing that's attached to that one transistor, pull the transistor up, go down in there, clean that pocket out really good and clean on the pill board, and I bet you'll find that where the hole into the heatsink has got a little bit of a guarded lip on it. So hold on a second, I'll show you what you do to prevent that. So knowing full well that I'm going to literally rip this thing down to the bare bones, I'm not too overly concerned about little aluminum shavings. We're not going to reuse the transistors in here. This thing isn't going to ever... I got to rip it completely apart. So that's the reason I was not too overly concerned about drilling this thing in a cabinet. What you do is you take your drill bit and just put it in here and chamfer the hole out just a little bit. Just a hair. You don't want to take too much surface area away. That also gives it a little migration space for the heatsink compound when you go to apply the transistor to the heatsink for the compound to wick into. There are certain technicians out there, like my good buddy Tech 9. He'll take a X grit amount of sandpaper and the whole surface area where the transistor is going to attach, he sands it. And it's not very aggressive. It's a very, very, very light amount of sanding. But what that does is it gives it grooves. And really, it's kind of increasing the amount of surface area overall that the transistor can sit upon, and it gives it a place for the cream to go to. I am of the other school of thought. I want that transistor or the heatsink to be as delicately smooth and flat and clean as I possibly can get it, and use a minimal amount of transistor thermal compound that I can use. Because if we look really close, focus, you fricktard. If you look really close at the ears of the transistor, you'll see that they have a cant to them. They're not perfectly flat. So as you're torquing down the transistor, which is 25 inch-pounds per screw, if your screws are going in at this angle and the screw head makes contact with the transistor, it literally torques the center of the transistor down. So I've tested it both ways, and you know, there's a lot of different options that are available to us. That's the best one of them all, in my opinion. More on this to come in the future. But, all that being said, ooh, shiny drill pedals, nice and good, straight up, good. So, next step, we're going to start ripping this thing apart, and we're going to start cleaning all the pieces as we take it apart. We're going to take off each panel and stuff. I'm going to leave the back and the front panels attached, so we'll only do one panel at a time. And eventually I'll probably just leave this side off. But where I was going with this is the clutch-o-matic is big. It's like about this big. Okay. Normally, like I said, I'd want to take it over, put it on the drill press, neat, and just nibble at it. You just peck at it. Peck drilling. But I'm telling you, when that bit breaks off in here, you're screwed. Your only option is to take the whole thing apart, take all the pieces off or support it somehow, and then re-drill the heatsink fin from the back side and then get in there with a punch and knock on the end of the bit and maybe knock it loose enough to where it'll come out of the hole. And that'll allow you to salvage the heatsink. Other than that, man, they make all kinds of little fancy-dancy, as seen on TV, tools that go in there and supposedly are able to get this and that, and it either damages the heatsink face to the point where you've got to resand and, you know, polish it out smooth again, or the cost and the time and the energy, throw it in the fuck it bucket and go grab something new and put it underneath the board. I'm telling you, if you're not able to pre-line them out, you are flirting with the devil and you're asking to get burned. So, okay, let's start ripping the bottom side off this thing. All right. Around here someplace I've got some really fancy octopi camera stands. I bought all this fancy stuff when I first started shooting these things because I got tired of using the phone. And my good friend, Mr. Black, to which I owe a lot of my flexibility for this thing too. In the beginning, he's like, "No, you make the best video you can." So that screw is completely chooched. All right, gotta love rust. Give me a second. Had to cut a slot in it. Anyhow, like I was saying, my good friend Mr. Black, he told me to go out and just do the highest production video that I felt comfortable with. Right. And, you know, we went out and we got all that equipment. Sometimes that equipment takes longer to set up than it's functional for the shot. Okay, so this Dave made Moby. All right. Look at this. strip them good. So this thing's obviously been wet at some point or another. I'd feel better about things if the heatsink wasn't cut off at here and actually went back here to the mount holes. That way the transistors would be a little bit more spaced, but the fact that the heatsink goes all the way to the front of the cabinet is good. In today's apparent market terror for the big production, where I was going with that big speech before I got sidetracked is sometimes it's easier just to grab a little something and prop up what you're doing. Remote wire's off. Prop up what you're doing and get on with the show. These videos represent an insane amount of time and energy. I mean, I don't ever charge a customer for the video, but I'd have to say half of my time that I spend working on something is dedicated to the documentation of the work. And this all comes from, I mean, in the beginning, back when dinosaurs roamed the earth and YouTube was in its infancy, you know, if you didn't have a name, nobody trusted their work you were doing. And of course, okay, now that I got all ripped apart and the board cleaned up, I wanted to cover something. So here's our actual amp section. I took this out because it's just, I'm going to replace the pill strips and everything. This thing's been chewed up and it was really dirty. So I'm going to take one continuous board and put it in here. And when we come back on the next segment, there'll be 4 transistors in here. Plus I'll have the driver replaced. But, so remember this is orientated like this in here, right? So this transistor here is the one that I think is a fake, because the print's not square on the transistor and all that kind of stuff. I wanted to show you the bottom of the heatsink, or the bottom of the transistor. You see all the little bits of metal and stuff, like, grab a dental pick so we can get that to focus and not be glared out to beat all. So there's a little piece of goo here, and another little piece of goo here, and here, and here. What has happened is somebody changed the transistor, and in the process of changing the transistor, got shmoo into the pill pocket. I remember in a couple segments ago here in the same video, I was talking about how the aluminum can gall up and cause an uneven surface. And if the transistor isn't in there smoothly, let's look at its paired up partner. You see the heat sink or the transistor on the right, your camera right? See how clean the bottom of it is? That means it had uniformal connection. Look at the transistor on the left. Lots of shmoo in the pill pocket. But look at what was down inside of the heatsink cream. Look at this. That's in there. I mean, that's not like a little fluff. That's galled up aluminum from having the transistor changed, or a little piece of solder that's down in there. So the transistor isn't sitting flat, it's sitting cockeyed. That's probably why this pill kept popping on you, Mr. Curtis. So here's all the stuff I've taken out of it so far. I went through and I repaired the faceplate, cleaned it all up. It's all cleaned up, looks like new. Repaired the on-off switch. Fixed our LED that was punched in. Tested our variable. And now we're in the return side of the thing. So now we're going to start putting it together. I pulled out the relay, which is right here. Pulled out the relay. You know, steal some parts off of here and start putting it back together. But we're going to put it all back together, all new hardware, and it's all been clean. So now we have the best chance for success. And the pill pockets are all cleaned out as best as we're going to be able to get them. So now it's time for us to start putting it back together. Trust me, this thing's going to work good. Doom, doom. Doom, 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 down. Down. Doom, doom, doom. That's what was down in the bottom of that pill pocket. It was a little chunk of solder stuffed down in that hole. Smushed flat by somebody else screwing the transistor down. So what we take away from this is I got to be super careful I've got extra long screws that sometimes I have to use on this kind of situation. Thank God the screws that we use don't fully penetrate the heatsink. That particular hole for that pill pocket has been stressed because somebody's really super cranked down with a screwdriver. It was a grooming job. And yeah, we'll be able to overcome that. But okay, let's put it together. I'm thinking about starting a Patreon channel. Yeah, if I do one video a month over an hour and a half long or an hour long or whatever, it's this whole video thing is very time consuming, but I sure am grateful for it, and I've had a lot of fun with it, and it's really helped establish who I am. Now I had to start the whole video thing here many moons ago to show the customer what I was doing, because I was kind of new to the game, you know. How little did I know it would turn into what we have going on for us today. How little did I know. But here we are, no worse for the wear. We're having fun. So, in certain circumstances, it's much easier to change out the entire pill strip. The entire pill strip than it is to try and add to what's already there. There's some strength that is gained structurally in the device by going this route, and that's what I was after. That, my friend Curtis here, he's been in the game a long time, and I want to afford him the opportunity to enjoy this. Okay? The whole goal here is it's not about the building of the amp, is what I was getting at before the phone rang. And I swear, all I got to do is turn this camera on and the phone starts ringing. It's about trying to keep the radio hobby alive. That's more important to me than making money or that, and being able to do the repairs and help keep people's equipment still running. That's our major goal. So what I'm doing now is that's where I was going with that whole train of thought. Sorry, I'm a little scattered, super busy over here today. What I'm doing now is I just pulled the transistors out, and I cleaned up the output transformer, this guy, which was pretty skunked up from all the soldering and desoldering and all the stuff over the years. And just smoothing down all the high points in the solder and cleaning it up so that it doesn't look like chicken poo. Make sense? But the YouTube channel, I sure have enjoyed this, and I sure have enjoyed being able to get out here and do all these things, and I've done so many videos and so many amps at this point. It's just absolutely silly. Okay, so cleaned up. Here's our new one that we're going to install here. Let me run over here and get 1,000 puff metal mylar. This is such an essential component to the device that I can't believe people are trying to use substitute components. I've done many videos about this particular cap. There for a minute, they were a little hard to get a hold of, and there was a lot of people that went out there to try and find supplements for it. And of course, that led them right to Alibaba and some of the Chinese parts, which we very well established are substandard and don't hold up to the pressure. They might hold up to the short term, but they don't hold up to real life. You know, like the guy in, let's say, Arizona maybe, just pulling a state out of my mind, no particular circumstance or person in mind. The guy in Arizona that's got no air conditioning in his truck, it's 122 degrees in the shade, and he goes to start operating his CB radio or his amplifier, his 10 meter amp, whatever, and all the components inside the box are already at 120 degrees. I think you guys can see where I'm going with this train of thought. That part's already well past its operational limit, because it's going to heat up. The parts will heat up, and these output transformer, or the output capacitors, and the output transformers, this little guy, arguably one of the hottest components in the box that doesn't have a heatsink attached to it. So he's already got this part that's super saturated to its core at 120 degrees, and then he goes to talking on it and spends 2 hours talking on it. Meanwhile, that cap's in there just going, oh God, and it's getting super hot. Where if you go and you test these in your shop, where it's air conditioned and the component's been sitting on the shelf for half a day, and it's come down to its natural ambient air temperature, so it's not super saturated with heat. You're going to sit there and run it 15-20 minutes. The parts, you're going to spend half that time getting up to temperature. So the metal mylars last much better. They put up with a great deal more punishment. So I'd rather spend a couple extra bucks knowing that I don't have to worry about it. The guy that's getting something repaired by me is going to have his best chance, best opportunity to be able to have the thing run for years and years and years. And I'm not going to lie, it's ultimately comes down to being less work for me and more enjoyment for the customer. So stick with the metal mylars. So let's go over here and let's grab a 330. Let's grab a little bit of wire, because we'll pre-wind, preload this thing before we put it in there. And then I'll show you guys what I've got done on the inside. I'll spend a minute talking about it before we get that far. So where we're at now with the inside of this thing is all 5 of the transistors are in. Pill pocket's been cleaned. The appropriate screws have been added in the right place. And transistors are down. I had to go in there with a little scraping pick tool that I have and kind of clean the copper down so I had good contact with all the new parts that we added up. Solder this, solder there. A little bit of dab and a little bit of jab, and we're done. Okay, so the board is preloaded. Let's go ahead and prep up and prepare here our new input transformer. More than meets the eye. Most of the time it's easier to do all this stuff outside the box than it is to try and do it inside the enclosure. Okay, let's show you what we got going on the inside. So all 5 of the transistors down. This one's done. I got to add a 1000 puff capacitor here. All new pill strip, all brand new 120s, all brand new 10 ohm resistors, and small enough so when the transistor collapses, we have the right field depletion to ground. The right collapsing effects will take place, and the resistor isn't going to just get hot. It is going to physically break down, which will give the next guy who's got to come in here and repair it in the future, if it's not me, the next person will be able to see, oh look, there's a part with this component here, instead of having to guess for a hot minute. Because really changing these to a higher wattage resistor doesn't do you any good. They pretty much sit there idle and don't do squat until the field collapses inside the transistor, and then you have voltage starting to run back. Anyhow, yeah. As So where we're at, we're going to go ahead and start loading the cabinet. We're going to put the input and the output transformers in here, and we're going to run our power wires and start getting our combiner and splitter all put together. Once I get that done, I'll be back. This has been a rough day. Between all my phone calls that I get from my business, plus all the other business phone calls today, man, today has been rough. Curtis, you're going to love this. This is the inside of your 2x4 now. Does not look anything like what it did when we started. So, got all the power wires in, new power wires going out the back, new grommet, of course, 4 new transistors, 4 new pill strips, yada yada yada. So now all I got to do is bolt up the face, get the face on, get the side rail on. I want to go through it all the way through it and replace. We got a couple other screws and stuff that we're going to do. I should have just taken this completely out of the cabinet and drilled it in the drill press. It would have been much easier. I didn't think I was going to go to this level with it, but like I said, the goal is to make the experience for the customer a positive, good one, and to give them the best product that we can give them. That's the goal. So, on that note, while I'm doing this hardware change out and putting this thing back together, I'm going to return probably something like 45 missed phone calls of my own today that I need to take care of. So let's see, it's 7 o'clock in the evening now. We started on this thing at noon, intermixed with all the other stuff. It's going to be a long, long evening. But we're going to get her done for you, Curtis, because that's what we do. Anyhow, on that note, we'll be back. So this is the one I think is fake. Here. Focus. There we go. You can tell by the print. See what I'm saying? See the Toshiba? According to the DC Pro, no component detected. Garbage. Okay. Test the 2290 driver. It's got a gain of 25. Right on. Still usable in something else, maybe. Gain of 8. Borderline on its way to the grave. Anything usually below about 9 doesn't want to hold together. So, bag up all of Mr. Curtis's parts here. Got me a little baggie to put these in. Man, you don't want to go in a hole. Go in a hole. God, I had a girlfriend like that one time. Didn't want to go in a hole. I miss her in some aspects. Don't miss her in others. Okay. Off and down the road. Curtis, you're going to like this. Okay, so it's all back in one piece. Replaced your fan. We got literally the old school Radio Shack. Ooh, it's ready to go. Okay, replaced your fan. Now please note, Curtis, I did flip this around so that your on-off switch is now up and down. Okay. Variables all set up. Now we're going to run the derail radio. Let me go ahead and shut the amp off here real quick. Let's show you what we're base dead keying. 1.25 watts. Okay. Peak power is 1,000 watt slug and peak, 1,000 watt slug and average. About 18, 19 watts peak. Pass through tune is a 5 watt slug and reverse. Nice and low. Let's go over here. I'm turning the slug around, by the way. Let's go over here. Look at the spec ant. And you can see on cursor 2 at 54 megahertz. We can see just a little bit of the radio's oscillation, but no big deal. Hello, hello, 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Pretty much spectrally pure. Wouldn't expect anything less from Mr. Derail. So let's go ahead and kick on the 1x4. Ooh. Why are we so high? There we go. Turn the radio down a little bit more. So now I got to revalidate all my data. Okay. Oh, this amplifier is hot. Woo. All right. Half a watt. Kick the amp on. 100 watt dead key. Swing at about 800 peak. Average. About 425. 1 2 1 2 1 2. It's not spectrally too bad. Got our sideband starting to hop up there a little bit. A little bit above noise floor at the 54 megahertz mark. So I'll take clean any day of the week. Big monster average numbers. Just put the lid on it. Now Curtis, we stripped this thing down to nothing. And I know I've had to call you a couple times and tell you I'm coming, it's working, I'm gonna get to it, we're gonna do it, this is where we're at. We're done, Curtis. I went ahead and I added your old Anderson clip. I stripped the old power wires off there and then put your old Anderson clip back on there. These are all soldered and staked in there and everything the way it's supposed to be. Curtis, listen to me when I tell you this, my friend. This amp is going to last a long, long, long time. And you're going to have a lot of fun talking on it. This has been a long day, you guys. Very, very busy for me. I've still got about 30 phone calls to go, and it's about 8 o'clock at night. Let me show you my phone. Let me show you something. This is about my average day, and this is just my personal phone. This is all the phone calls. Just in this day alone. And I've still got at least another 20 more that I gotta go. Guys, be patient. Listen, if you call and you go to voicemail, I don't listen to the voicemails that often. I normally just go off the called return history, okay? If you get the voicemail and it's full, don't call back again. I will see that you called, and I guarantee you I will call you before I go in the house every evening. I'm doing the best I can with the amount of workload that's being presented to me, and I am so grateful for it. I can't even describe how grateful and thankful I am for all the support that you guys give me. Even if it's the guy like today who called in the middle of the day around lunchtime and I was actually able to answer the phone, and he asked me how to set his SWRs. So I spent 20 minutes on the phone, talked him all the way through it, and now his SWRs are all set and he's good to go. That's what we're here for. We're here to help each other. We're here to create things for each other. We're not here to talk trash about each other. I got a 32 pill up here today just because the guy called me up and he says, man, I watch everybody's videos, and he goes, you're the only one that doesn't ever trash anybody. That's not my job. My job is what I did today. Take something completely apart, repair it, restore it, modify it, put it all the way back together better than what it was originally, and just repair the box. All the other stuff, all the Facebook drama, all the other stuff, all the little groups, I don't have time for it. I'm too big for it now, I'm too busy for it now, and I've never been enjoyed or involved or cared anything about it. This right here making this happen for you guys is more important to me than anything else. And to be able to take care of my friend Curtis today, who's been here multiple times, makes me inside happier than anything else in the world. On that note, guys, I gotta go. I'm pretty tired. I've got a whole lot of phone calls I gotta return. I've got at least another hour and a half of radio, and my day started out here at 7:30, 8 o'clock this morning. So I didn't get out here till about noon, but still, it's been all day on the phone. I appreciate everybody's patience. I truly appreciate everybody's patience. I'm going as fast as I can. I'll see you guys. If this is the first time you've ever tuned in and checked out one of my videos, and you enjoyed what you've seen, click subscribe. And even at that, while I'm doing phone calls, I gotta sit down and edit the video. Just saying. Seriously thinking about a Patreon channel. Seriously thinking about that. I really am. Guys, I gotta go. We'll see ya. Bye.